Okay, welcome everybody. Yeah, attendance is pretty sparse, which I expected. I can't really compete with an eclipse, but hopefully you all saw my announcement today. I am hoping to end class at about 1:45, 1:50 at the latest, so that we all have time to get out there and join everybody else in front of Brookings and uh, take a look at the eclipse later on today. So that shouldn't cause any interference. That should be enough time for us to get through what we were going to get through today anyway. Just wanted to make sure you're all aware of that. Some other things that I want to make sure you're aware of and just kind of get on the video record for the people who aren't here today. The exam 3 is coming up next week. So next Thursday will be exam 3. It's going to be just like the other exams, just over different content basically. So 1 week from today on Monday, we'll be here in this room doing an exam review session. Thankfully there's no eclipse that day, so I hope everybody will be out here reviewing for the exam. I also wanted to give one quick note about the final exam, which I know is still at least 3 or so weeks away. I forget the exact date of it. But I do know that the final exam falls during Passover this year. I've been made aware of that fact. I just want to make it clear that if you have a conflict with the final exam due to a religious observance like Passover, while the course policies say there are no makeup exams, the policies can't cover every situation. This is an example of a situation where course policies don't really make a whole lot of sense. So if you want to take the final and you have issues with that because of Passover, please talk to me. I want to talk to you and make sure that we get that worked out in a satisfactory way. So just wanted to make sure everybody was aware of that. Otherwise, I'm going to keep things rolling right along, hop into today's topic. We're kind of looking forward today. So this is the last new stuff that I'm going to be introducing this semester for the entire course. And we're kind of starting to get you geared up for higher level comp sci topics, higher level computer science topics. The big destination for a lot of people after they take this class is a class called CSE131, Data Structures. And so what I'm going to introduce to you today are a couple of new data structures. And so what I mean by a data structure is simply a way of organizing our data. Some data lends itself to be organized in a certain way, and it's up to us as computer programmers a lot of time to examine the data that we have, examine the data that we want to use with our code, and then decide on how that data should be structured within our code. So getting to know the different types of data structures is important. And then in 247, you'll actually get a deep dive into some of those data structures and really understand at a deep level how they are working. But for now, we're mostly interested in just driving them, right? So like, I don't know how an engine works in a car, but I know how to drive one. That's kind of the goal today. I don't expect you to know how all of these data structures work under the hood, but I do expect you to be able to learn enough to be able to drive them and use them in your code when you need to. So that's kind of the goal for today. The first data structure that I'm going to introduce to you is called a list. So we're looking at a page right now that describes the list as an interface. This is actually somewhat similar to the inheritance concept that we covered last week. What an interface allows us to do is to group things together by shared behavior that they have in common. And so, there are more than one kind of list that exists in the world, but all lists have the same interface, meaning that I can perform the same actions upon them, right? Again, to kind of use the analogy of a car, right? Cars also have a common interface. If I get into a car, it doesn't matter if it's the car that I own or my friend's car or just some random car that I'm renting somewhere, right? I expect the interface to be the same. I expect for there to be a gas pedal that makes the car go. I expect there to be a brake pedal that makes the car stop. And I expect there to be a steering wheel that makes the car turn in whatever direction I need to go, right? That's true for all of the cars that I've ever personally come into contact with. I know there's maybe some exceptions to the rule, but in general, the interface of a car is a couple of pedals and a steering wheel. And you can also imagine that, for some jobs, maybe I need a small car. Maybe that's the best tool for the job. And for other jobs, maybe I need a big car. Maybe I'm hauling a bunch of stuff home from IKEA and I need a big car. And so in those situations, I want to use the tool that's most appropriate for the job. I think the important thing to understand is that regardless of whether I use the big car or the small car or whatever version I'm using, the interface is the same. I push the gas pedal to go, push the brake pedal to stop, turn the steering wheel to turn. The same idea is true in code. So the two kinds of lists that I want to introduce to you today are called array list and linked list. Where linked list is probably the version that I would expect you to learn about in 247 when you take it and when you take 247 sometime in the future. But these are both just different types of lists. So again, using that car analogy, if we look under the hood of an array list at what the engine is doing, right, it would look different than if we looked under the hood at what the linked list is doing. But the way that I interact with those two lists is the same. So I can put things onto the list, I can remove things from the list, right? I can ask, what's in this position? Those are all actions that are the same regardless of what type of list I'm actually using. So this interface tries to encapsulate that by grouping these common behaviors together. And I'm not going to go through every single part of this interface, but I am going to touch on some of the more common methods that we expect to use. This is covered in the text as well if you've done the reading for today. We have an add method here to add elements to a list. We have a get method to retrieve an element from the list at a certain position. And then we also have a remove element here to remove items from our list. And the nice thing about these lists is that they provide us some functionality above and beyond what arrays can provide. So it is true that lists and arrays feel kind of similar. They do have some similarities. In fact, in just a minute, when we look at the code, I'm going to contrast them directly. Here's how I do this with an array. Here's how I do the same thing with a list. The nice thing about lists is that they provide some things that arrays can't for us. For example, when I create an array, that array is defined at a certain size, and it is that size forever. I can't change the size of an array after it's been created. That's not true for lists. Lists can grow and shrink depending on how many elements they contain, right? Lists are objects. Lists are objects. So the way that we use lists is just the same as we use any other object. I have to create an instance of it by calling the constructor, and then I call methods upon that instance with the dot notation that we've seen in prior classes. Whereas arrays, we don't really do stuff like that. We see that square bracket notation, right, when we're using arrays. That's not going to be true anymore. We're not going to see square brackets in use with our lists. Other things, though, they do share in common. Lists are indexed, meaning that they have buckets that start with 0 and count up 0, 1, 2, 3. And I can place things into the list at certain positions, just like I can with the array. And so in that sense, they're kind of similar. In fact, they're oftentimes used for a lot of similar purposes. If it were up to me and I were implementing the roster of students on assignment 7, for example, I would probably use a list, because I think a list would be a more flexible, easier way of approaching that problem than using an array. We ask you to use an array simply because we haven't shown you lists yet, right? Arrays certainly work, certainly get the job done. I think for most programmers, however, they would probably prefer the flexibility that's provided by a list as opposed to an array. That's not to say that you'll never use arrays again. They do have their place, they have their purpose, they're very handy and easy to use. But you're going to start to see these object versions pop up more and more and more and more. And so what I would like to do first is just kind of give you an introduction to how to use lists. I've got an example here using arrays, right? So here's an example using arrays. I've decided to make an array to represent the rainbow, where I stick each of the colors of the rainbow into the array at its corresponding position, right? And I would like to rewrite this code now using a list instead of an array, just to kind of compare and contrast how these two things work. Before I do that, I just want to take 1 second to mention that arrays and lists are both used to represent sort of the same kind of data. So that was the first question or the first kind of concept that I mentioned at the top of class is, we have to decide what data structure to use depending on what data it is that we're trying to represent. So what kind of data are we representing with lists and arrays? Well, we have an index. We have this number that always appears consistently in the same order. And so arrays remember the order of our data, right? If this thing is at a certain position, it will remain at that position until I move it or remove it, whichever the case may be. So if we have data where the order matters, where order is something that is important to us, that is a good indication that we should be using an array or a list, actually preferably a list. Lists maintain order. Not all data structures do. And I'll show you an example of a data structure that doesn't maintain order in just a little bit. But lists maintain order, and actually anything that you would consider using an array for is probably also a pretty good candidate to use a list for. You'll learn about more applications, as I said, if you take data structures, CSE131 after this. But let's start at the top, and what I want to do is just kind of replace each of these lines with a line of code that will do the same thing, just with a list. I'll try and explain what I'm doing as I go along. So up here at the beginning, we're creating a brand new empty array of strings. We can do that with a list as well. It looks a little bit different, so already you can tell that things are looking a little bit different than how I am using, my arrays to do things. For starters, I'm going to call the constructor here. So I am calling the constructor. Let me take a moment to explain the syntax and also explain why Eclipse is angry at me. For starters, I think I just need to import these things. So I'm going to import list. I'm going to import the thing called linked list just by letting Eclipse do that. You can see these imports got added for me automatically at the top of the file. So Eclipse is very good at detecting when it needs to do that and importing those things for me in order to use them. We see a new little bit of syntax here. Those are called angle brackets. It's called angle brackets. This is what's called a parameterized type. So when I'm creating an array of strings, an array of strings, this is what this looks like. When I create a list of strings, it just looks a little different. It looks like this, where the type of the thing contained in the list goes inside of angle brackets. We're not using square brackets anymore. When we're using these lists, it's going to be angle brackets. Okay? This is calling the constructor. You might notice that this does not match the type that I've listed over here, right? Also notice that I have the angle brackets over here, but it's not filled in. You actually can, if you want to, fill it in. It's just not required. It's considered redundant to say it in both places, so a lot of times you will see them blank over here. These parentheses, though, are a big indication that I am calling a constructor. I'm calling a method. Specifically, I am calling a constructor, a linked list constructor. This will create a brand new empty linked list. One thing that you'll notice that's missing, I didn't say how big it's going to be. I don't have to. That's no longer a requirement for lists. That's something that we do have to say for arrays, but lists are just going to grow and shrink depending on how many items they contain. So that's not something we have to specify up front anymore. Okay? And now down here you can see all of this code is broken because, this is the array way of doing things. Name of the array, square brackets around the index, equals whatever I want. Well, that's not how things are going to work with our lists. In order to do the equivalent thing with the list, we're going to use, again, from the interface here, we're going to use the add method. So, whoops, wrong button. There we go. If I come back here, what I need to say, remember, rainbow is an instance of an object now. It is not an array. I changed it so it can be an instance of an object. So I need to call a method upon that object, and the method that I'm going to call is add. This method will automatically add whatever element I give here to the end of the list. Since I just created the list here, this is going to get added to the end of the list, which is position number 0, index number 0. And I can do the same thing for all of the other ones. In fact, I'm just going to do a little copy-paste action down here to replace all of these other statements to do the same thing, right? Oops. There we go. Just got to put the closing parentheses on here. All right, and now, after these lines execute, we'll have a list that contains the exact same items that the array contained when I had this same code up here using an array. And then finally, let's take a look at this example down here. Here I'm trying to retrieve a value from my array and print it out. So if this was an array, this is how we would do this with the, again, with the square bracket notation. But that's not what we're using anymore. We're using lists now. So I need to treat them as if it's an object. Rainbow dot. And then which method do we need? Well, you can scroll through the list and try and find one that seems like it would look appropriate, but the one that I know that we need is right here. It's called get. And then I specify the index that I want. Lists start from 0, just like arrays do. So this code here that I have should be functionally equivalent to the code that I had up here with an array when I first opened up this file. These two programs are doing the exact same thing, just using a different data structure to make it happen. And that's important. Again, as computer scientists, it's actually to our benefit to write code that allows us to swap out the data structures. Again, if I need to use a certain type of list in one situation, I want to be able to swap it out for a different type of list if the situation changes. And the way that this code has been written, we actually can do that quite easily. Here I've declared this new list as a linked list, but there's another type of list. Actually, there's many. But the other type of list that I'll introduce you to is called an array list. And actually, if I want to switch the type of list that's in use, all I need to do is switch this line right here, and then of course import the new type of list that I'm using. And you can see that now the code is actually still 100% functional, but it's using a different type of list. Again, this is very, very, very important, right? Some tasks might require a certain type of list, or require might be a strong word. They might just work better, right? More efficiently, take less time if I use a certain type of list. Again, this is more of a topic that you'll explore in 247 than in this class, but it is very, very, very important to us as computer scientists going forward. For the purposes of this class, the most important things for you to understand are just the basics. How do I use lists? How do I create a list? How do I add stuff to the list? How do I get stuff out of the list? Et cetera, et cetera. Any questions about lists before I introduce the second data structure of the day? Second and last data structure, actually. So there is a package here called sets. I'm not going to cover sets. I was on the fence as to whether I was going to cover sets or not, and I've decided, no, not going to cover sets. Sets will not be on your exam. Sets will not be on your homework assignment. Sets won't be covered in this class, period, at all. So I'm going to skip over that and jump down to the third topic, maps, which are a very, very, very different type of data structure to both lists and arrays, but also, I think, one of the most common data structures that you're going to find. It's extremely common and extremely useful. And so I'm going to open up the phone book example and show you how we use something called a map. The way that maps work, okay, so if I have a list or an array, those are going to be indexed starting at 0 and counting up, right? So first element's at 0, second element's at 1, so on and so forth. A map says, well, what if I don't want to use numbers as my index? What if I want to use something else as my index? And that something else can be literally anything else. So it could be a string, it could be another object, right? What we really want to do is make associations, an association between this thing and this thing, where we actually have names for those things. The stuff that we're storing in a map are called key value pairs. So there is a key that is associated with a value. Whenever I store something into a map, I have to give you both of those pieces of information. This key is associated with this value. When I retrieve something from a map, all I do is tell you what the key is, and then the map tells me what the value is. So that key, again, can be anything. It could, theoretically, be an integer that goes 0, 1, 2, 3, 4, right? But usually it's not. Usually it's something else. And so in this example, we're creating a phone book. We're creating a phone book using a map. And the way that the map is constructed, you see, we have two types here. The first type is the type of the key. And the second type that's listed is the type of the values. So the idea here is that I'm going to have a name, somebody's name, mapped to their phone number, like a phone book. The phone book would. So if you plug in my name, you would get my phone number back then. the idea of the map. So somebody's name, that's a string. I'm going to use strings as my key type. Somebody's phone number I have listed here as an integer, so I'm going to use integers as the type of the value. Very, very important when creating these maps to understand that you have to provide both of those types, not just one type like we do with a list or an array, but two types, one for the keys and one for the values. So once we've created this map, again by calling the constructor, we're calling the constructor here, we can start to take a look at what the map contains and start putting things into the map. So I'm going to go ahead and run this program so we can look at some of the output that it generates. When I first create this map, there's nothing in it. If I print it out, you can see here that I'm just printing out the entire map. You can see that it contains nothing. So those curly braces are usually a good indicator that you're using a map. There's nothing in them. The map is empty. If I go to the map and I say, hey, how big are you? What's your size? It's telling me that the size is 0. That all makes sense. I haven't put anything into the map yet. And now I'm asking, what is the phone number for Ghostbusters? What's Ghostbusters' phone number? And there's nothing in the map. So you can see that when I say, hey, tell me what value is associated with this key, again, we're using the get method to do this, it tells me that the answer is null. There is no phone number. You haven't told me what it is yet. I can't give you a value for this key. I don't know what this key is. You haven't actually put any key value pairs into this map yet. It's empty. So there's nothing for me to tell you. That's an important thing to understand though. If I try to retrieve something from the map that doesn't exist, the map is going to tell me null. The map is going to say null. Have to be careful for that. If you get null back and you aren't aware of it, that can cause errors. So it's something to be aware of when you're using maps. All right, let's put some stuff into the map. The way that we do that is with the put method. So when I put something into the map, I have to provide two pieces of information. I have to provide the key and the value. So here, this is the key. Notice that the type matches the same type that I specified the key would be when I created the map. And this is the value. So I'm saying that Ghostbusters has a phone number of 55555. Right? That's the Ghostbusters phone number. Notice that it also matches the type. Once we put that information into our map and we print out the contents again, we can see that, now we can see what our map looks like when it has stuff in it. Here's the key, here's the value that it's associated with. Okay. The size of the map is now 1. It has one key value pair. That's what determines the size. It has one key value pair. And then if I want to say, hey, tell me what the phone number is for Ghostbusters this time, right? I say phonebook.get. I plug in the key, which is, again, Ghostbusters, and it happily tells me that Ghostbusters' phone number is all 5s, right? All right, well, let's keep going. Let's put some more stuff into our map. I'm going to add a couple more people, right, to our map, and we'll take a look at it again. Here's our map after we have added a few more people to it. You can see, but let's pay attention to something here, right? Ghostbusters was the first number I added to the map, but it's not the first thing that I'm seeing, correct? So this is a trait of maps that is very important to remember. Lists and arrays keep track of the order of the data that they contain. Maps do not. The order that things appear in maps is not standard. Okay? It's not fixed. It can be in any order. The order does not matter. Okay? It's an important thing to keep in mind. All the key value pairs are there. It's just if I swap the order of these, it's still the same map. It's still equivalent. It's still the same map. The order that these appear does not matter. Unlike it does for a list, unlike it does for arrays. The size is clearly 3, and you can see that if I start retrieving items, so here I'm asking, tell me what the Ghostbusters phone number is. Tell me what Jenny's phone number is. Tell me what Saul Goodman's phone number is. And it happily will spit back all of those phone numbers. Again, it doesn't care about the order. It cares about the keys. I'm not saying tell me what phone number lives at index number 1. I'm saying, tell me what phone number is associated with the Ghostbusters, right? So I'm not using an integer numeric value. I am using key value pairs. And then finally, let's talk about this example of duplicates. So what if I want to change a phone number? Here you can see that I'm putting another phone number in here. Ghostbusters is already in there. They already had an entry in the phone book. I'm trying to put them in again. So what's going to happen? Well, let's print out our map and see. I'm going to come back down here, put in one more print line to print out the phone book so that we can see what happens to the Ghostbusters phone number after I try to put it in for a second time. All right, if I examine the output that I see here, you can see that before it was all 5s, and now it's not. And now it's not. What you don't see, it does not show up twice, right? It only still shows up at one time. Maps do not allow for duplicate keys. A key can only exist in a map once. So if I try to put another value in for a key that already exists, it is going to replace that value. It is not going to make an additional entry. It will replace whatever is already. No duplicate keys allowed. Values, however, can be duplicated. So if I wanted to make, in fact, we see that here, right? We can see that both Ghostbusters and Saul Goodman have the same phone number. That's okay. I can have duplicate values in my map. I cannot have duplicate keys, which kind of makes sense. I'm using the keys to look up the values. If I have one key pointing to multiple values, then I don't know which one you're asking for, right? There's always a one-to-one connection. One key points to one value, period. End story. These are very, 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 very useful, again, when trying to kind of map two sets of data onto one another, right? That's where the name map comes from. I'm literally creating a map from my keys to my values. I'm mapping. Cool. Any questions about maps? I have one more topic to discuss and about 15 minutes left before it's eclipse time. Any questions on this before I switch? All right. So the next topic that I want to introduce to you, the last topic actually, has more to do with objects generally than with lists or maps or data structures. I want to talk to you about equality and what it means for things to be equal. We actually have two definitions of equality that we're interested in talking about now. So one definition of equality is asking, right, I have this variable and I have this variable. Are they actually the same thing? Are these two variables actually talking about the same thing? As in, are they literally the same object, right? This variable and this variable are both talking about the same object. We have another version of equality, which is I have two variables, I have two objects. Are they equivalent in terms of, what they can do and what they contain? Not necessarily the same object, or I would describe it more as like they're twins, right? I have two objects that are identical, but they are distinctly separate, right? They're identical twins in a way. Let me try and illustrate this example in more detail using some code to illustrate what I'm talking about. Here is a person class, and honestly, I'm not too concerned about, how this class works because we've covered that in prior weeks. What I am interested in is this code down here that starts creating some person objects and comparing them. One of them is comparing, or we're comparing in two different ways. I'm comparing using this dot equals method, and then I'm using double equals. So before now we've seen double equals and used double equals for basically all equality comparisons that we care about. But objects make this trickier to deal with. And I'm going to draw a little diagram and try and explain the difference between this type of equality and this type of equality. So let me open up MS Paint here real quick and start drawing some stuff. The way that I think about these problems is whenever I see a line like this, I'm calling the constructor, I'm creating a new instance of an object. And then the left-hand side of the equal sign, that's just a label. That's really just a name, a label that I'm applying to this instance of the object that I've created. So if I wanted to draw a diagram that represented this instance, this object that I'm creating, it might look something like this, where I make a circle, right? And then inside of that circle, I'll have two instance variables, name, John Smith. This text is very small. Let's see if I can make this a little bigger. Maybe? Okay, good enough. And the ID is 1. To represent the fact that I have this label, or actually the computer sciencey term for this is called a reference. This is called a reference. In order to represent that on my diagram, I would draw an arrow. So I would take, draw some kind of an arrow and say that there is a label called P1 that is pointing at that object. So I have this person object, and I have a label called P1 that is pointing at it, a reference called P1 that's pointing at it. On the very next line, you'll actually see I do the same thing again. I create another instance. The name is the same, but the ID is different. So these are two separate people that happen to have the same name. That happens all the time. There are people with the same name. And there are other Doug Shooks in the world. I know that for a fact. I've Googled myself just like everybody else has, right? So, again, how do we represent this in our diagram? Well, anytime I call the constructor, anytime I see that new keyword, that's an indication that I'm making a new instance. And inside of that instance, it'll contain, the appropriate instance variables. This time the name is still John Smith, but the ID is 2, right? And the reference that is pointing to it is called P2 this time. So I would indicate that on my diagram as well. P2. Make this bigger. Okay, cool. So here's what the code kind of looks like after we execute these two statements. And the question is this true or false? How are we doing equality here? How are we saying if two things are equal or not? When we're doing dot equals, when we're using dot equals, the code is going to examine the instance variables to determine equality. So if I'm asking the question, P1 dot equals P2, what I'm really asking is, do these instance variables match up, right? And the names do, but the ID number doesn't. And I would actually argue that that's the more important one of the two for us to care about anyway. I actually don't care if the names match. It's possible for two people to have the same name. But if I've given two people different ID numbers, I would think that's two distinctly separate people. So because the two ID numbers don't match, these are not equal to each other. And if you were to run this code and take a look at the first print statement, it'll say that P1 dot equals P2 is in fact false. Okay, let's keep going. Let's take a look at this line right here. I'm making a new variable called P3, a new person variable called P3. I am not calling the constructor. I know this because I don't see the new keyword, right? Don't see any parentheses anywhere. So what is this piece of code actually doing? It is creating not a new instance of an object, but a new reference or a new pointer is what you might hear that referred to as. If I refer back to my diagram, the way that I would indicate that is by making a new arrow that points to this already existing object, right? So we really now have two labels. We have two ways of accessing this same person. we do this all the time in real life as human beings. Very possible to relate this to how we see things in daily life. My label, my reference here on campus is Professor Shook. My kids don't call me that. At home, my kids call me Dad. My wife calls me Doug, right? So all three of those things, Professor Shook points to me. Dad also points to me. Doug also points to me. All three of those are referenced to the exact same instance, me, right? It's only when we call the constructor that I have a new instance. So, okay, how does this affect our conversation about equality? Let's take a look. The next thing we're going to take a look at is P2 dot equals P3. So dot equals, again, I want you to kind of get this drilled into your mind. Dot equals means look at the instance variables. Are they the same? So P2 is pointing here, and I can see the instance variables. P3 is pointing here, and I can see the instance variables. Yes, they are the same. Absolutely. So I would expect P2 dot equals P3 to be true, and in fact it is. However, let's talk about the other type of equality. P2 double equals P3. What is that asking? That is asking if P2 and P3 are pointing at the same instance. Are the arrows for P2 and P3 pointing at the same circle? I don't care about the instance variables. That is not what I'm interested in at all. I'm asking, are P2 and P3 pointing at the same instance? And the answer is yes. In this case, they are, in fact, pointing at the same instance. Absolutely. And so we see that P2 double equals P3 is, in fact, true. In fact, we can take this one step farther and say, if double equals is true, then dot equals must also be true. If I'm determined that both references are pointing at the same thing, then the instance variables must also be the same. It's the same thing, right? The same thing. So if double equals is true, then dot equals must be true. The opposite case, however, not always true. So let's take a look at that example. I'm going to make one more person object. And this time, person P4, you can see, I'm calling a constructor. There's that new keyword. There's the parentheses. I'm calling the constructor. So this means I'm going to add another circle to my diagram to represent that instance. You'll notice that the instance variables are exactly the same as the one that P2 and P3 are pointing at. So the name is John Smith, and the ID is 2. The reference that we have pointing at this is called P4. All right, and so now we'll ask our questions again about equality. Does P4 dot equals P3? Dot equals says look at the instance variables for both of them. So here P3 is pointing at this instance and P4 is pointing at this instance, but if I look at the instance variables, they are the same. So dot equals true. It's the identical twins scenario, right? Dot equals is checking for identical twins. Two objects that look exactly the same as each other. That's what dot equals is checking for. And if you check the output down here, you'll see that P4 dot equals P3 is in fact true. Okay, but then let's talk about double equals. Our next task is to look at P3 double equals P4. Here we're asking, do the arrows point at the same instance? They very clearly do not. They very clearly do not point at the same instance. There are two separate instances that happen to look the same. So double equals is checking to see if these two arrows point at the same thing. They don't. Double equals then is false. And actually, if you take that one step farther, P2 is the same thing as P3, So also a different instance, right? Or, just to give you another way of thinking about this, for double equals to be true, the thing on the left and the thing on the right have to be the same thing, right? If this statement is true, that means that there's only one instance here. T3 and T4 are referred to the same instance. That's what it means for double equals to be true. If double equals is false, that means that you have two distinctly separate instances. There are two different questions, right? Two different questions. One of them is asking if I'm looking at the exact same object or not, and one of them is just asking if they're identical things. Subtle variations, yes, but different questions that have different uses in different contexts. And it's important as programmers to understand those differences so that we know when to use double equals and when to use dot equals, because it does matter. It does make a difference. All right. I wanted to finish by 1:45, and I think I'm done. So a few minutes ahead of time, unless anybody has any questions, I'd like to go out and watch the eclipse with everybody else in front of bookings. So that's where I'm going to go. But let me know if you need anything, okay? And I'll see you in labs later on this week. Thanks for coming today. Appreciate it.